Plans for Operation Weiner Roast were made here at the Atomic Energy Commission building in Idaho Falls. And the experiments were conducted at the National Reactor Testing Station 53 miles away in the valley of the Lost River Mountains. Although these pictures were taken in the middle of March, the peaks were still covered with snow. Careful preparations were made to approximate actual conditions, so the body of a real airframe was brought to the Twin Buttes Desert. To record essential data, weather stations were set up and direct gamma reading instruments strategically located. From inside the airframe, the jet fuel oil can be seen at the bottom. For better burning, holes were cut in the sides of the fuselage. The nuclear fuel element had to be kept centered in the flame, so the jet fuel oil was arranged in a teardrop shape. And to check biological effects of the experiment, arrangements were made with the local volunteer Rabbit Corps. They didn't mind a bit. Intensity of radiation was measured by direct gamma reading instruments placed 3 feet above the ground. By using portable electrical instruments and mobile power supplies, it was possible to get around and monitor the results from almost any point in the test area. Filters were used to sample the solid material in the air. Before and after both phases of the experiment, radiation measurements were made by means of walk-ins along 8 radial lines. To study the upper air, blimps were sent up to heights of 500, 1,000, and 1,500 feet. Attached to each were a series of vacuum jars which were automatically opened, samples taken, and then automatically recorked for analysis at a more convenient time. The most difficult part of the operation was considered to be the accurate placing of the hot fuel element. Proper test position was accomplished by using a crane with a 90-foot boom. Before the final decision was made to proceed with this experiment, 5 trials were necessary. Equipment and procedures were studied, personnel were briefed, and detailed observations were made of the weather conditions, the terrain, and particularly the burning characteristics of jet fuel oil. It is a credit to the skill of the operator that he was able to put the fuel element into a relatively small red funnel, despite an annoying 15-mile-an-hour wind. This shows the position of the fuel element. Before the experiment could be started, conditions had to be just right. Everything had to be checked and rechecked. The instrumentation was made within a 45-degree sector. If the experiment was repeated, this would be increased to 90 or perhaps even 180 degrees. Unfavorable winds caused delay, and smudge pots were set out to determine whether the wind on the ground was the same as indicated by the blimps. After postponing the experiment for 4 successive days, word was given to begin, and the first blimp was sent aloft to its designated height. Thermite starters were needed to set the oil on fire because jet fuel has a tendency to develop resistance to combustion when it remains overnight in cold weather. Previous attempts with black powder proved to be ineffective, so a battery of 5 thermite starters were installed, and each one of them ignited successfully. When ignited, the blaze is clearly visible. but automobile tires were needed to produce a large volume of dense black smoke. As the jet fuel oil burns vigorously, it envelops the nuclear fuel element. The purpose of Phase A was to simulate the crash of a nuclear-powered aircraft. The airframe used in the experiment is the fuselage of an actual plane. The skin is made of magnesium, and the supporting members are aluminum. The white smoke is the metallic oxide created by the intense heat. As the inferno continued, most of the magnesium and aluminum melted. Most of it did not burn away. This quadrupod rig was custom designed to help keep the fuel element upright throughout the experiment. But without consulting any of the scientists, a workman substituted a brass nut for one of the steel ones he had damaged. As you will see later on, the brass nut melted and one of the legs of the quadrupod collapsed. This caused difficulty in precise evaluation of data. The flame continued for almost 2 hours. And as the fire raged furiously, the temperature soared to 2,250 degrees Fahrenheit, higher than in any of the previous trials by at least another 100 degrees. It should be noted that none of the preliminary work involved the use of actual materials. Prior to Operation Weiner Roast, the mock-ups did not include an airframe, nor was the nuclear fuel element included in the stainless steel container. Not until final agreement was reached by the planning committee was any scientific attempt made to determine what would happen if a radioactive fuel element was subjected to conditions simulated by the crash of a nuclear-powered plane. With direct gamma reading instruments, fallout plates, and the rabbits acting as biological indicators, air samples were taken as far as 1 mile downwind. It had been anticipated that if there was a comparatively small amount of radioactivity, about 5 or 10%, the loss could be easily verified. All that was required was to check the results of the walk-ins before and after the experiment. Even though the wind kept shifting back and forth through approximately 40 degrees, there was no difficulty in obtaining all the essential data. The first time this experiment was mocked up, a circular pond of jet fuel oil was used. But with a 12-mile-an-hour wind, the fire stayed beyond the end of the container. However, with the teardrop shape, a maximum flame was maintained around the fuel element. At the bottom of the fuselage, the white metallic oxide flame may be seen. This, together with the automobile tires, made quite a sight, visible all over the upper Snake River Valley. The ground wind at the time had a swing of close to 20 degrees. The test crew was fully prepared for this set of circumstances and took the precaution of tying the blimps to trucks, which just had to move back and forth to keep the apparatus in the main plume of the smoke. The airframe was expected to melt down completely and collapse, but the quadrupod was carefully designed to hold the fuel element in a constantly vertical position, to allow for the walk-ins along the radials for checking the loss of radioactive materials. However, when one of the legs gave way, the fuel element fell and the radial picture was distorted. For a time, it appeared that the loss was as high as 50% because the radiation field went down immediately. The truth was discovered before the experiment was concluded. That ring is the top of the stainless steel rope holding the fuel element. In a certain sense, it's almost unfortunate that there was no release of radioactivity. No opportunity was presented to measure the spread of radioactivity. Originally, it was assumed that if the nuclear fuel element did catch on fire and burn, the radioactive materials would follow in the trail of the smoke. This conclusion is still not certain. At the end of the experiment, only one problem remained unanswered. How could the fuel element be safely removed from the molten mass of magnesium and aluminum? After examining the nature of the melted metal, some of the crew went back to the shop and made a couple of special tools. This one is a long stick with a hook on the end. And with the use of manpower alone, the fuel element was pulled loose from the solidified metal. This view is somewhat distorted because the telephoto lens makes the men appear closer than they actually were. The other tool made in the instrument shop was a grappling hook, now being held at just the right angle by those ropes, so that the crane can pick up the fuel element. This tricky operation took only an hour and a half because the operator had such acute depth perception. And that time includes the making of the tools. In addition to some dirt on the fuel element formed by a coat of melted magnesium and aluminum, a small triangular hole was discovered in the cladding. This indicated a puncture. When the fallout plates were developed, the amount of radioactivity indicated was insignificant. The air samples registered nothing. And with the exception of the two places where the fuel element fell, the survey instruments could not detect anything. Incidentally, the shape of the fuel element is still classified, so there are no close-ups of this procedure. Another thing not shown in this film was the initial attempt to drop the fuel element into the garbage can. It fell off the hook the first time and had to be done over. This is the second time round. There was no difficulty. The garbage can was then put into a shielded container and taken to the hot room, where there were facilities for comprehensive examination. Results of Phase A demonstrated that there is no release of radioactivity when a nuclear fuel element has been subjected to the intense heat of burning jet fuel oil combined with other reactor materials under these test conditions. The second phase of the experiment was organized to determine the effects of extreme heat on a nuclear fuel element. This time it was planned to raise the temperature to 5,600 degrees Fahrenheit, and the curies were increased to 10,000, twice the amount used in Phase A. Although no radioactive materials were used during the trials, everyone had a chance to preview the nature of the events to be observed during the actual experiment. The demanding nature of Phase B required about 10 mock-ups like this to guarantee an enclosure that would last a minute and a half. If there had been any contamination of the area, previous arrangements had been made to use another site for Phase B. Actually, the only changes needed were fresh filter papers and a new set of rabbits. The instrumentation remained the same. The test pipes were lined with close to 3 inches of magnesium, filled with iron filings, steel wool, and thermite. To intensify the heat, oxygen was added by means of a cylinder connected to the pipe, and the valves were turned mechanically from a distance of 200 yards. As the experiment proceeded, not all the well-rehearsed movements ran smoothly. For one thing, the wind freshened up to about 20 miles an hour, and the crane operator had trouble hitting the funnel, even though it was painted red. To further complicate the situation, the fuel element stuck twice before it was successfully lowered down into the interior of the pipe. Despite these minor delays, the second phase of the experiment began within an hour and a half after the completion of Phase A. After the preliminary radio walk-ins, the thermite charge was set off, and the first smoke went sailing in a direction which the rest of the smoke did not follow. This went all the way to the Westinghouse plant, 5 miles in the distance. This is a closer view of the thermite starter. The closer shots appear darker because of differences in photographic exposure among the 3 cameras. With the exception of the smoke which drifted to the Westinghouse plant, everything went according to plan and resembled the pattern of the trial mock-ups. Watching from the field as dusk descended, it looked like a spectacular display of fireworks, complete with Roman candles. But there were drawbacks, too. None of the blimps was in a position to get an air sample. They were all too high and out of the path of the downwind. This was somewhat disappointing, because great pains had been taken to make sure the survey instruments would be able to record the results. Since radioactivity can easily be detected if there is 1,000 curies per distance mile, 10,000 curies were put into that torch. In this phase of the experiment, the integrity of the fuel element was completely violated, and the release was estimated to be up to 10%. The great bulk of the activity remained within a radius of 50 feet, but with survey instruments, it was discovered on the ground and on sagebrush for about 2,000 feet. Activity was well contained in a plume of about 25 degrees and couldn't be found beyond 2,000 feet, except for the air filter samples in the neighborhood of the Westinghouse site. Nothing definite could be determined from the radio walk-ins after the experiment because of the shift in the winds. All that could be determined was proof of fission products all over the ground. Final lab reports later on proved the radioactive material was largely ruthenium, cesium, and the halogens, including iodine. It was all over in 90 seconds, but it was an unforgettable experience. Next day, the whole site was cleaned up in less than 3 hours. The area was bulldozed, the earth put into a Dempster truck trailer, and then hauled to the burial ground. Results of Phase B of Operation Weiner Roast indicated that with a temperature of approximately 5,000 degrees Fahrenheit and under the test conditions, the upper limit of radioactivity released was 10%, with most of this staying within a half mile of the release point.